Alright, now something that we haven't really discussed but probably need to discuss. Fault trees and state charts. The fundamental building blocks of our integrated functional and safety specification model. I'm going to give you a basic description of how they work, but I'm not going to be using PowerPoint presentation because I don't have the kind of time to incorporate it. My strong recommendation to you would be to read the Fault Tree Handbook and an introduction to UML state charts, maybe one of the tutorials in my files, and to watch our videos from last year. Ethan does a great job of introducing these two models, but I'll give you an idea of what I remember straight out of my head. Alright, you've got, with a fault tree, you've got events that are described in little boxes, just rectangular boxes. And you've got, it's a tree, like the name implies, it's a tree. And you've got the top level event, that top box, and that's the event that you never want to see happen. That's the catastrophe right there, that box that's imaginary right in front of me. Now, below that box, you'll have a bunch of AND gates and OR gates that I think probably resemble electrical engineering circuits in some sense, but I don't want to confuse you. We'll have a visual AND gate and a visual OR gate. An OR gate is shaped something like that. It's, got that oval and then kind of a curvy point at the bottom. And then it's connected to further boxes down here, separate boxes. And the way an OR gate works, of course, is if either this box or this box occurs, and again, these boxes are events, then they activate up. It's just like an electrical circuit. And this big event that we don't want to have happen occurs, but that's how it works. And then, of course, the other fundamental one is AND gates, which look very much like OR gates, except the bottom right here, it's still curved around the top, but the bottom is a flat piece. This simple syntax, it's either flat or it's curved, and those AND and OR, most fundamental building blocks you'll ever have in a fault tree. And with an AND gate, of course, you've got two or more events below the AND gate. You have to have you have to have all of those events occurring simultaneously for the signal to travel up the tree. So that's fault trees in a nutshell. You've got events in rectangular boxes, and you've got Boolean connectors between all of those boxes, and everything progresses from the bottom up. And you just don't want to have that top level thing activated. And as I said in previous videos, you just don't have a sense of time or order of events with traditional fault trees. So that covers fault trees. As far as state charts are concerned, you have a bunch of components in a system, and they have states. Say we've got a light bulb, and that light can be there either on or off. Those are different states. And you have events that cause a change of state for those, and states are generally kind of rounded or kind of curved edges, and they're contained within something that designates what object they are, generally speaking. So you'd have the big light bulb here, and you'd have two states inside the light bulb. So it could be either on or off. And you have events that are written along a line connecting these two dots that would cause a change to happen between those two. And naturally, the event that would cause a light bulb to go on or off is right. Now, I don't know. Maybe some of you said flick the switch. Maybe some of you, because you're smart butts, decided to say, well, you just have to walk in front of the motion sensor. It's still an event. You get the idea. So you have an event that triggers the state changing, and once you leave a state, there can be a specific thing that you say has to happen, and once you enter a state, there's a certain thing that you can say has to happen. And then while you're in the state, you can say just continue doing this, continue doing whatever this happens to be. I don't have any examples offhand of entrance and exit commands, but those are some interesting things to know. And let's see. I also talked about superstates in another part of this video series. You can have a bunch of different little components within a big component or a big state. A lot of times with state charts, we treat components as sections, but you also have to consider states, and it's kind of weird that both states and components can be the same basic building block, but that's kind of how it works out, because you'll have, if you've got, like I described in another video, you've got the full system, whatever it may be, and you've got debug mode and you've got production mode, completely different modes. But within those modes, which are like curve-edged boxes, you've got all of your components with all of the states that they could possibly be in. And they may have different behaviors depending on whatever super state they happen to be in. So, yeah, you've got objects or components that have different states that are changed by events. And that's fault trees and state charts in a nutshell. Hope that's helpful.